The most scrutinized commercial aircraft in aviation history is also the best-selling jet Boeing has ever made. It was grounded by every aviation authority on Earth at the same time, in 54 countries. 344 aircraft were pulled from service simultaneously. It made front-page news on every continent. 2 crashes, 346 people dead. And today, it is the backbone of short-haul aviation. It is on more routes, operated by more airlines, carrying more passengers than any other commercial jet flying right now. That is not a comeback story. That is something stranger than a comeback story. Before this video is done, you will understand exactly how that happened, and why several of the facts inside that story are genuinely unlike anything else in commercial aviation history. Starting with the one that stops most people cold. When the Boeing 737 MAX entered commercial service in 2017, the pilots flying it had no documented knowledge that a critical flight control system existed on the aircraft they were operating. The system was called MCAS, the Maneuvering Characteristics Augmentation System. It was software running in the background of every flight, capable of pushing the nose of the aircraft downward automatically, overriding pilot inputs, and doing so repeatedly without a clear warning that it was the cause. It was not in the pilot manual. It was not covered in the differences training that pilots completed before flying the MAX. Airlines operating the aircraft had not been formally briefed on its existence in any meaningful operational detail. The pilots of Lion Air Flight 610 and Ethiopian Airlines Flight 302 were not facing a system they had been trained on and failed to manage correctly. They were fighting a system they did not know was there. That single fact reframes every conversation about what happened. To understand how that was ever possible, you have to go back almost 60 years. The Boeing 737 first flew in April 1967. That was 4 months before the first Saturn V rocket launched, and 2 years before Neil Armstrong stepped onto the moon. The original 737 was designed for a world where commercial jets were still a relatively new idea. Airports were smaller, and jet engines were narrow and compact enough to hang cleanly under a low-slung wing. That airframe, that basic tube, that fundamental geometry, is the direct ancestor of every 737 MAX flying today. Boeing did not design a new aircraft for the 21st century. They updated the same one again and again. The 737 Classic in the 1980s, the Next Generation series through the 90s and the 2000s, and then the MAX, launched in 2011 as a direct response to Airbus announcing the A320neo family. Think about what that means in physical terms. The team that designed the original 737 did so using slide rules. The aircraft they drew is now fitted with fly-by-wire systems, composite materials, and touchscreen cockpit displays. The bones are nearly 60 years old. Everything built around them is modern. That tension between an ancient geometry and a modern mission is the reason the MAX exists at all, and the reason it ran into trouble. Because the engines were a problem from the beginning. The CFM LEAP engines selected for the 737 MAX are significantly larger in diameter than the engines on any previous 737 variant. More efficient, more powerful, considerably bigger. And the 737 sits low to the ground, unusually low compared to most modern commercial jets. That was a deliberate design choice in 1967. It made ground handling easier at smaller airports with less equipment. In 2011, those same low-slung wings created a direct conflict. The new LEAP engines were too large in diameter to hang in the traditional position under the wing without the engine nacelle sitting dangerously close to the tarmac. Think of it like this. Imagine you have a bicycle that has been in your family for decades. It works well, the frame is solid, everyone knows how to ride it. Now you want to fit it with much larger wheels for better performance. But the frame sits so low that the new wheels scrape the ground at the bottom of every turn. You cannot raise the frame without rebuilding the entire bike, so instead you reposition the wheels slightly, forward, angled differently to clear the ground. That is almost exactly what Boeing did. The LEAP engines were moved forward on the wing and angled slightly upward to clear the tarmac. It solved the ground clearance problem, but it changed the aerodynamic behavior of the aircraft in a specific flight condition. At high angles of attack, the repositioned engines produced a tendency for the nose to pitch upward more aggressively than on previous 737 variants. Left unaddressed, that handling difference would have required pilots transitioning from older 737 models to complete full simulator training on the MAX. That is where the story takes the turn that defined everything that followed. American Airlines had placed an enormous order for the A320neo before Boeing launched a MAX competitor. Boeing needed to win that business back. The pitch to airlines was straightforward and commercially powerful. The 737 MAX would be so similar to fly that existing 737 pilots could transition with a short iPad-based differences course. No full simulator sessions, no type rating. That meant airlines would not need to pay for expensive simulator time, would not need to schedule pilots offline for extended retraining, and would not need to negotiate with unions over new aircraft classifications. It was not a trivial selling point. For a large airline operating hundreds of pilots across a fleet, the difference between simulator retraining and a tablet course is worth tens of millions of dollars. MCAS was the system engineered to make that promise deliverable. It was software designed to make the MAX feel like the previous generation 737 in the specific flight conditions where the handling difference appeared, smoothing over the aerodynamic consequence of moving those engines so the aircraft's behavior remained familiar enough to meet the no new simulator training commitment. It was not written to make the plane safer. It was written to protect a sales agreement, and the way it was implemented made it catastrophically vulnerable to a single point of failure. MCAS received its data from one angle of attack sensor. 1. That sensor was a single vane mounted on the exterior of the fuselage, measuring the aircraft's pitch relative to the oncoming airflow. If that sensor provided incorrect data, if it was damaged or malfunctioned or was struck by something on the ground, MCAS had no second source to compare it against, no cross-check, no validation. It simply received a number and acted on it. On a normal commercial aircraft, critical flight systems pull from multiple redundant sensors, precisely because a single point of failure in a flight control input is considered unacceptable. MCAS was designed with only one. When that sensor malfunctioned on Lion Air Flight 610, MCAS received a signal indicating the nose was pitching up dangerously. The system activated and pushed the nose down. The pilots countered. MCAS activated again. They countered again. The system had no way to know its input was wrong. It kept pushing. The crew had not been told that MCAS existed and were uninformed and had no rapid procedure available to identify and disable it in time. The aircraft entered the Java Sea 13 minutes after takeoff. 5 months later, the same sequence of events brought down Ethiopian Airlines Flight 302 in 6 minutes. 54 aviation authorities grounded every 737 MAX in service within days of the second crash. 344 aircraft, every single one. It was the broadest simultaneous grounding of a commercial aircraft type in the history of aviation. Nothing had ever been shut down at that scale, that fast, across that many independent regulatory bodies at once. The 737 MAX sat on the ground for 20 months. The financial consequences for Boeing were unlike anything the company had experienced in its modern history. $20 billion in costs, compensation payments, legal settlements, and production-related losses. $20 billion. To put that in perspective, that is roughly the annual GDP of a country like Iceland or Honduras. It was money spent not on building something new, but on repairing the consequences of something that should not have been allowed to leave the factory floor the way it did. And after $20 billion and 20 months, Boeing's answer was not a new aircraft. It was a corrected version of the same one. The economics of designing a clean sheet replacement were simply too large to absorb on top of the losses already incurred. So Boeing worked with the FAA through what became the most exhaustive aircraft recertification process in the agency's history. 197 specific changes to hardware and software, thousands of hours of additional test flights, independent review panels, congressional hearings, an entirely new framework for how the FAA certifies aircraft, where manufacturers have a commercial interest in the outcome. MCAS was fundamentally rebuilt. It now pulls data from 2 angle-of-attack sensors and compares them. If the readings disagree beyond a defined threshold, the system does not activate. It is limited in how aggressively and how repeatedly it can move the flight controls. It can be overridden cleanly and quickly. Pilots now receive simulator training on the MAX, specifically covering MCAS and its operation. The aircraft that emerged from that process in November 2020 was not identical to the one that was grounded. And the certification process it survived was more rigorous than any other commercial jet has ever been subjected to. Independent aviation safety analysts have noted the uncomfortable irony directly. The MAX is now one of the most thoroughly examined commercial aircraft ever cleared for passenger service. The scrutiny that followed the crashes produced a level of regulatory examination that most jets flying today were never subjected to. By the specific metric of hours of regulatory review per system, the MAX that flies today has been looked at more carefully than almost anything else in the sky. And most of the people sitting on it right now have no idea what they are on. Airlines renamed it quietly. Southwest Airlines calls it the 737-8. United lists it in booking systems simply as a 737. Ryanair, which operates the largest MAX fleet of any airline on Earth, refers to it as the 737-8200. The branding of the MAX name was so badly damaged that most carriers made a deliberate commercial decision to make it disappear from customer-facing communications. The plane that was on the front page of every newspaper on Earth for 2 years is now boarding at a gate near you, listed under a name most passengers do not recognize, operated routinely on thousands of flights a day across every major aviation market in the world. That is the full arc of the 737 MAX. A 60-year-old airframe. Engines too large for the geometry they inherited. A software system built to protect a sales promise rather than solve an engineering problem. A single sensor with no backup. 346 lives. $20 billion. 20 months grounded. 197 fixes. And a return so complete and so quiet that the aircraft is now invisible. The machines doing the world's work are almost never as simple as they appear from the window seat, and the decisions that shape them are almost never purely technical ones. If that changed how you think about the next boarding pass in your hand, this channel has more where that came from. There is an entire layer of aviation decision-making that passengers never see. The economics, the certification compromises, the competitive pressures that shape what gets built and how. Hit subscribe, and we will keep